welcome back to World and today I started to floating ink.
So today we got a simple experiment using dry erase markers, and I'll show you in a second some sort of dish to draw on and some warm water. So you just need some sort of pitcher of warm water between 120, 140 degrees. And this ceramic butter dish works well to write on. Corningware dish, small glass Pyrex, or the larger glass Pyrex, or even this stainless steel spoon did work. It didn't work as well though as the ceramic or the glass. So looking online, we did a little research, and we found a lot of people suggested using these Expo dry erase markers. But what I have found is these Viz Pro dry erase markers. They seem to work a little bit better. They seem to release a little bit easier than the Expo markers. We bought many different colors of the Expo markers, and not all of the colors work the same. Some don't seem to want to come off at all, some do. So we don't bore you with drawing hundreds of pictures in different colors. I chose 3 because the Viz Pro markers only come in red, blue, and black, or at least that's what I had on hand. So I just chose to use the red, blue, and black Expo markers as a direct comparison. As we show you and demonstrate this experiment, I'm going to discuss why this works scientifically.
Imagine this. You draw a cute little stick figure on a plate using a dry erase marker. Then you pour water over it, and like magic, your drawing lifts off and floats on the surface, wobbling around like it's alive. So what sorcery is this? Well, it's not magic, it's science. Let's break it down. The chemistry of the marker. Dry erase markers are especially designed not to stick permanently to surfaces. Unlike permanent markers, which use strong adhesives and pigments that soak into materials, dry erase markers use nonpolar solvents, typically alcohol-based liquids like isopropanol or ethanol, mixed with color pigments and a silicone-based polymer resin. That resin is super important. It forms a slippery layer that prevents the ink from bonding chemically or physically to surfaces like glass, ceramic, or plastic. It just sits there on the top of the surface like a sticker. This makes dry erase ink hydrophobic, meaning it repels water. Think of it like oil and water. They just don't mix. The ink is also less dense than water, and that's the key for the floating trick. Surface tension and floating. Now enter water, our everyday superhero with some serious science behind it. Water has a property called surface tension, caused by the cohesive forces between water molecules. It's like an invisible skin across the surface of the water. It's what lets bugs like water striders walk on water, and it's also what supports the floating dry erase drawings. When you slowly pour water onto your drawing, 2 things happen. The water seeps underneath the dried ink, breaking the weak interaction between the ink and the plate. Because the ink is hydrophobic, it doesn't absorb or dissolve, it lifts cleanly off the surface, riding the tension of the water like a tiny boat. And voila, your drawing is not floating. As the water moves or shifts, it drags the ink drawing around with it. That's why it wiggles and drifts like a cartoon come to life. This effect is enhanced if your surface is really smooth, like a glass plate or ceramic bowl, because there's less friction between the ink and the surface, making it easier for the ink to peel off. If the water is too hot or too cold, or if the marker isn't truly a dry erase marker, the trick might not work. Permanent markers, for example, won't lift. They bond too tightly. Also, the more complex your drawing is, the more likely it is to break apart as it floats. Simple shapes like hearts, stars, or stick people float best. So in short, floating marker drawings are possible because of 3 main factors: the chemical makeup of the ink, nonpolar, hydrophobic, lightweight, the surface tension of the water, the non-stick nature of the smooth surface beneath. It's a perfect mix of chemistry and physics, and a fun way to visualize some deep scientific principles with just a plate, a marker, and some water.
Thank you for watching. It's a fly.
Thank you for watching. Please like and subscribe.
Thank you for watching in a fly, and thank you for watching.
No. Thank you for watching. Please like and subscribe.
I cannot do it, so yes.
Thank you for watching another episode of Aurora's Little Lab. Please like and subscribe.